Once again, welcome back. In this part of our lecture, I'm going to talk about osmosis. During this part, I'm going to talk about the definition of osmosis. What does the word mole mean? Molarity, osmol, osmolarity, molality, osmotic pressure. I'm going to talk about these things, okay? So first of all, what is osmosis? It's so easy. Osmosis is, keep it in your mind that osmosis is the passive movement of water. Osmosis, the passive movement of water, but how? Like this. Osmosis is the movement of water from low concentration solutes area to the high concentration solutes area. For example, in this container, in this A part, I have 6 solutes, okay? In this part, I have 20 solutes in B parts. So where is more concentration of solutes? Here is in B part, I have more solutes. So here, water, I have equal amount of water. So the movement of water from low concentration area of solutes to high concentration area of solutes through semi-permeable membrane. Through semi-permeable membrane is called osmosis. Here is a question. You will think that why these solutes don't come here? Because this membrane is semi-permeable. It don't allows these things or these solutes to move from this area to this area. So here solutes will absorb water to its cells. So osmosis is the movement of water through a semi-permeable membrane from low concentration area of solutes to high concentration area of solutes. So this was easiest part of this osmosis. Now let me talk about mole. What is mole? Okay, it's so easy. Let me give you firstly an example. Be careful here. This is an atom. You know, atom is the smallest part of an element. This is an atom. For example, this is carbon 12 atom. Why I say carbon 12? Because we have two types of carbon, carbon 12 and 13. But here I have carbon 12 atom. If I divide this carbon into 12 pieces, which carbon? Carbon 12. If I divide this carbon 12 into 12 pieces, each piece is equal to 1 AMU, atomic mass unit. This is a standard unit. For example, I have 1 meter. This is a standard unit. I have 1 kilogram. This is a standard unit. Like this AMU, atomic mass unit, this is a standard unit. So if I divided carbon 12 into 12 pieces, each piece is equal to 1 standard AMU. So 12 pieces is equal to 12 AMU, or atomic mass unit. If we have something which is called atomic mass, for example, atomic mass of carbon is 12. Atomic mass of carbon is 12. It means that it is 12 AMU. If I say that atomic mass of oxygen is 16, it means this is 16 AMU. If I just tell you that atomic mass of nitrogen is 14, so this means that this is 14 AMU, and each AMU is equal to 1 piece of to 1 per 12 piece of this carbon 12. This is so easy. Okay, so now because 1 AMU is so small, I can't do an experiment. I can't do chemistry with this. I can't touch it. This is so small. So we came, okay, and we made a unit for this atoms, and these units are called mole, and these units are called mole. What's mole? Let me give you an example. Mole is only a name. For example, if I tell you that give me 1 dozen of banana, so you will give me 12 banana. If I tell you that give me 1 pair of eggs, so you will give me 2 eggs. So pair is here only a number, a name. Dozen is only a number or a name. So here mole is also a number or name. If I tell you that give me 1 mole of banana, you will give me this number of banana, 6.02 times 10 to 23. This is so huge number. This is about 602, 1, 2, 3. This like this number, this so huge number. So we don't use this huge number, this mole, for large things. We use this number for small things like atoms. Okay, so now if I tell you that give me 1 mole of carbon, so you will give me this amount of number, and this number is also called Avogadro's number. Okay, if I tell you give me 1 mole of carbon, so you will give me 602 times 10 to 23 numbers of carbon. Okay, it's so huge number. It's so easy. Now if I tell you this is so important point, listen me carefully. If I tell you that 1 mole is how much AMU, or I tell you that give me 1 mole of AMU, so how much number of AMU you will give me, how much pieces of this carbon you will give me. For example, if I tell you give me 1 mole of AMU, you will give me 602 10 times 10 to 23. You will give me this amount of AMU. If I tell you give me 1 mole of AMU or 1 mole of these species, so you will give me this number of these species. Okay, so if I change it to molecular weight or to gram, it's equal. Listen carefully. 1 mole of AMU is equal to 1 gram. It's so important. What does it mean? You know, this amount of AMU, this Avogadro's amount of AMU, this amount of pieces of this carbon is equal to 1 gram. If I take it and I put it in a balance, it's equal to 1 gram. So after this, for example, if I tell you that give me 1 mole of carbon, so in gram you will give me 12 gram. In gram you will give me 12 gram, because 1 mole of this AMU is 1 gram, and this is about 12 AMU. So if I tell you give me 1 mole of this carbon, so you will give me 12 grams. For example, for oxygen, if I tell you give me 1 mole of oxygen, in gram you will give me 16 grams. If I tell you give me 1 mole of nitrogen, in gram or molecular weight, you will give me 14 grams. So now I can do experiment, I can do chemistry, anything with 1 mole of substances. Okay, you know, C6 C6H12O6, this is a glucose. Molecular weight of glucose is around, or atomic mass of this glucose is around 180 AMU. Now if I tell you give me 1 mole of this glucose, so you will give me 180 gram of glucose. Okay, now anyway, this was about the mole. That mole is only a number. Okay, how much? This amount of number. Now, what is molarity? What is molarity and what is molality? This is so easy. For example, if I take one mole of a substance, each substance, for example, carbon, nitrogen, or oxygen, anything. If I take 1 mole of a substance and I put it in 1 liter, this is molarity. Molarity. Liter. Here is also R. Liter. Molarity. Okay, so we write it in large M. For example, if I tell you that in this solution I have 5m of HCl, so it means that I have 5 mole of HCl in 1 liter. Okay, but what does mean with molality? Molality means that 1 mole, that molarity means that 1 mole of substance, it's writing by small m. Molality means that 1 mole of substances in 1 kg, in 1 liter, no, not in 1 liter, in 1 kg. Okay, so here is one big difference. Keep it in your mind. Come here to example. For example, first of all, about molarity. Okay, molarity. This is 5 mole of HCl. Okay, this 5 mole of HCl. Now, firstly I should put here 5 mole of HCl in this beaker. Okay, then I will add water. On this 5 mole of HCl till I reach to 1 liter mark. So as a collectively, this is all a solution. This solution is collectively 1 liter. So I tell you that 1m is equal to the number of these solids or these mole per solution. Okay, per solution. It means I have 1 mole in molarity. I have 1 mole of substances in 1 liter solution. And molality. Firstly, I should prepare about 1 kg water. Then I will add, this water is, as you know, this water is solvent. This water is now solvent. When I add to this solvent 5 mole of this HCl, so now this is, for example, 1 kg plus 5 mole. This is called molality. It means in molarity I have 1 mole of HCl or 1 mole of some things in 1 liter solution, but here I have some things only in 1 kg of solvent. Here is 1 kg is fixed, then I'll add 1 mole of substance, and here firstly I should add 1 mole of substance, then I will add water till I reach 1 liter. This is the big difference between these two, that here I have 1 mole of solids per 1 kg of solvent, and here I have 1 mole of solids per 1 of solution. Okay, so this was so big concept, and this was about molarity and molarity. Practically we use molarity, and molality is so accurate. Okay, anyway, now what is osmol? Osmol is so easy. Osmol mean osmosis, mole means 1 mole. For example, if I have 1 mole of substances and it causes osmosis, it causes absorption of water, this is called osmol. So one, so what does mean osmol? Osmol means that a mole of substances that causes absorption of water, this is osmol. So osmol is dependent on number of particles. This is so important concept. For example, if I tell you, if I add, this is glucose, this is glucose. If I add, for example, here, this is a beaker, okay? If I add this glucose into water, glucose is not dissociate. They not go apart from each other, okay? So that's why 1 mole of glucose come here, 1 mole of glucose, 1 mole of glucose is equal to 1 osmol. 1 mole of glucose is equal to 1 osmol because they do not de-associate it. And osmol is dependent on the number of particles, not on the size of particles. For example, I have sodium chloride. This is sodium and chloride. When I add this sodium chloride in water, they dissociate into sodium, and into chloride. Okay, they dissociate into 2 parts. For example, 1 mole of sodium chloride is equal to 2 osmol. It's not equal to 1 osmol. Why? Because 1 mole of sodium causes 1 osmol, and 1 mole of chlorine also causes 1 osmol. So that's why osmol is dependent on the number of particles, not on the size of particles. Okay, if you give someone 5 mole of sodium chloride, so it causes 10 osmol of osmolarity. Okay, come here. What's osmolarity and osmolality? This also so easy. It means osmoles per liter. This is called osmolarity. Like here was molarity, mole per liter. Here is osmol per liter. Okay, this also easy concept. Come here. I will give you about I will give you some examples about body osmolarity. Okay, don't worry. What's osmotic pressure? Then I'll talk about body osmolarity. What is osmotic pressure? Come here. This water moves to this direction, from direction A to direction B. If I put some pressures here, if I put some pressure here to prevent the movement of water from part A to part B, this pressure is called osmotic pressure. This pressure is called osmotic pressure. Sometimes it can cross over the water from B to A side. Okay, for example, this water want to move here. Here is a lot of solids. Okay, if I put here some pressure and prevents from the movement of water from this area to this area, this pressure is called osmotic pressure. And keep it in your mind, it's previously calculated. Keep it in your mind that 1 mole is equal to 1000 millimole, and 1 osmol is equal to 1000 milliosmoles. So keep it in your mind that 1 milliosmol, 1 milliosmol causes how much osmotic pressure? 19.3 pressure. For example, a body osmolarity is about 290 or 300 milliosmoles. So if you multiply it to 19.3, it causes approximately 5000 millimeter Hg pressure. Anyway, I don't go there. Let me clear a concept that our body osmolarity is about 300 or 290. Why? Okay, it's pretty easy. For example, let me give you some examples. Okay. Mhm. For example, this is intracellular area and this is extracellular area. In extracellular area, I have 140 millimole of sodium. I have about 100 millimoles of chlorine. I have about 5 millimoles of glucose. I have about, for example, 2 millimoles of magnesium, about 2 millimoles of calcium, and also I have some other things. If I calculate all of them in extracellular area, for example, 140 plus 100 is 240, and this is 250, and some other things, which when I calculate all of this, for example, they are equal to 290 or 300 millimoles, because these particles are not disassociated more further. So sodium is now alone, chlorine is now alone, all of them are now alone. If I calculate them, so each millimole is equal to 1 to each milliosmole. So I can tell that body osmolarity is 290 or 300 milliosmoles per later. Okay, this was extracellular osmolarity. Like this, intracellular osmolarity is equal to this, because for example, inside of the cell I have 140 millimole of potassium, I have bicarb, I have proteins, and some other things. Okay, so they are equal. Why? Come here to the concept of tonicity. Tonicity, we use this term when we compare two types of solution. For example, this is intracellular area and this is extracellular area. So here, this beaker is extracellular area and this cell is intracellular area. For example, if I put this RBC in a type of solution in which the amount of solutes in extracellular area and in intracellular area is equal, so water don't move from the inside of the cell to the outside of the cell, or from the outside of the cell to the inside of the cell by osmosis. So this type of solution is called isotonic solution. So if you give someone isotonic solution, so this solution will not move to the inside of the cell or not from the inside to the outside of the cell. But if I put this RBC in a type of solution in which the concentration of solutes is in which concentration of solutes are more outside of the cell instead of the inside of the cell, so this type of solution is called hyper hypertonic solution. So in hypertonic solution, the water is moving from the inside of the cell to the outside of the cell by the process of osmosis, because here is water channels. Okay, so in this hypertonic solution, cell goes to shrinking. Cell is shrinking. Okay, but if I put this cell, this RBC, in a type of solution in which the inside part of the cell contains more solutes, in the extracellular area we have less solutes concentration, so water will move from the extracellular area to the intracellular area. Okay, and it causes bursting of the cell. Okay, so cell goes to rupture, and this type of solution is called hypotonic solution. Okay, So this was the huge and toughest concept of the cell membrane, which I have explained. Osmosis definition, mole, molarity, osmol, osmolarity, osmotic pressure, molality, and so on. So learn it clearly. And